right, so section 9.5 is about different tangents to a circle and theorems and properties. All right, so first let's go over what a tangent to a circle means. This is not the same as the trig ratio, okay? So a tangent is a line or a segment or a ray that is in the same plane as the circle and it intersects the circle in exactly one point. So I like to think of a tangent as touches the circle, okay? Where the line or segment touches the circle is called the point of tangency. That's it. So a common tangent could be a line, a ray, or a segment. It doesn't really matter. So there's some scenarios that could happen. You could have two circles and there could be a tangent between them. So this would be a point of tangency and this would be a point of tangency. You could have two circles touching, and so believe it or not, it looks like there's more than one point, but there's actually exactly one point where those circles touch. Okay? So that's the idea. This line or segment is called the tangent, okay? Just for simplicity purposes. So let's look at our first theorem. This one will help set up other problems, but if you have a line that's tangent to a circle, it does touch the circle in only one spot, but also the radius and the tangent, they're going to be perpendicular to each other. So we say that ST is perpendicular to line L. Okay, and so that's it. All right, I don't think that's really obvious, so you can kind of see we would use that information later to maybe find missing values, triangles, things like that. All right, so let's look at some examples. So they tell you that JL is a radius of a circle, which we see, and it looks like it's length of 8. Determine whether KL is tangent to the circle or not. Well, if we have that KL is tangent, then what we want to know is that going to be a right angle? Okay, and they give us some other measurements. So if it's a right triangle, then that means that the Pythagorean theorem should be true. Okay, and so that's what we want to check. So we've got the two sides, so one leg is 15. 15 squared plus 8 squared, does that equal this whole hypotenuse squared? Because that's what would be. So keep in mind, I know the 9 stands for this length, but we want the whole hypotenuse. So if that radius is also 8 here, that means that that whole hypotenuse length is 17. And so we want to check to see if this is true or not. So 15 squared is 225, 8 squared is 64, and 17 squared is 289. So if we add these together, I get 9, 8. So since that's true, we're going to say yes. Okay, and my justification is that the Pythagorean theorem is true. All right, and so let's look at B. JH, so right here, is tangent to a circle at J. So they're telling us that this is tangent. Find the value of X. So I'm going to go ahead and set up a Pythagorean theorem since it is a right triangle. So one leg is X plus the second leg is 12 is equal to this whole hypotenuse. Now, I don't know what the value is, but I do know that that's going to be X plus 8 squared. Now, this is going to be a review from first semester, so it's been a while since we've had to use this knowledge. X squared, 12 squared is 144, and then we can't just square each of these terms, we actually need to write this out twice. So this is a pretty challenging problem, okay? And then we multiply. So x times x is x squared, x times 8 is positive 8x, then we do the inside, 8 times x, and then 8 times 8. Okay, I do realize if you want some extra help with that, please email me and I can help you with some of those problems. So we're going to go ahead and combine some like terms. We get x squared plus 144. And then on this side, all we can really do is combine those x terms. So x squared plus 16x plus 64. Now we want to get everything kind of to one side or the variables to one side. So I'm going to go ahead and move this x squared term. Remember, x squared and x are completely different. So if we subtract x squared and I subtract x squared, it actually goes away. So we're left with 144 on the left and then 16x plus 64 on the right. So then my x is on the right, we're going to move the 64 by subtracting it. So let's see, 0, 8, 80 equals 16x, divide by 16, and x equals 5. And that's all they were looking for. Okay. All right, part C. Find the value of x in each of these problems. Assume that the segments that appear to be tangent, that they are. So they're just not going to directly tell us. So I know that that's going to be a right angle. And we have another Pythagorean theorem. So we get 14 squared plus x squared. And this time they give us that whole hypotenuse length. So we get 14 squared is 196. And then 17 squared is 289. So subtract 196. So x squared equals 93. And then we'll take the square root. Now, technically, we should get a plus or a minus, but because we're talking about a circle, we won't have negative lengths. Remember, we're going to want to break 90 down. So I know that's 3 times 31, and that doesn't break down at all. So we're just going to leave this as root 93. Okay. All right. Part C, my second problem is kind of like D. I just thought we would try this kind of in a different way, though. So once again, this would be my right angle. So my hypotenuse is this whole length. This part is x, so this part is also x. This time you would have to write that in. So we get x squared plus 4 squared equals x plus 2 squared. And I'm going to go ahead and write that out twice, since I know that's coming anyway on my next step. All right, we'll try this again. So you're going to do x times x times 2, the inside, 2 times x, and then 2 times 2. Okay, so now this is the second time. 4 squared is 16. So once again, I can subtract x squared and subtract x squared, and they go away. So then we get 16 equals, combine these, plus 4. So we'll subtract 4. So 12 equals 4x, divide by 4, and x equals 3. And that's what they wanted, find x. Okay. All right, our next theorem, this one's pretty popular. It says that if we have this external point, B, from a circle, and then we have tangents BC and tangent BA drawn from B, then what happens is that these two tangents are actually congruent. Okay? So we know that AB is congruent to CB, the length. There's also some other corollaries to this. If I would draw in the length BD, these two angles are equal, as well as if we would draw in the radii, these two angles are equal. So there's a lot of different corollaries from this one idea. Okay, so let's look at example A. It says AB and CB, they are tangent to circle D. Find the value of x. So since these are tangent, those are equal. So x plus 15 equals 2x minus 5. So we'll subtract x. So 15 equals 1x, and then add 5, so x equals 20. For part B, same idea. Assume that the tangents that appear to be tangent are. So these are going to be very similar, and they just want us to find x. So I know these two are equal. It doesn't matter, see, where it's drawn. So 3x plus 8 has to equal 26. Subtract 8. So 3x equals 18. Divide by 3, and x equals 6. Same idea here. These two tangents are congruent. So subtract 2x. So 9 equals x plus 6, and subtract 6. These are typically integer values, but you never know. All right, the last thing we're going to talk about are different circumscribed polygons. So inscribed means inside, but if it's circumscribed, it means that the polygon is outside the circle, but it's touching it. Okay, does that make sense? So a few different shapes. Polygons that are not circumscribed, see this gap here, see how this doesn't touch it, and see how this is kind of like inside it too. So you can kind of think when we have circumscribed, if I ignore and I only look at this part, then I have a point outside and then I have these two tangents. So some of these theorems are going to apply if you don't look at the entire shape. Okay? So this says RSTU is circumscribed about circle J. It looks like it's touching. And if the perimeter is 18, find x. So what we know is, I'm going to look right here at P. TA and TB are both tangents. See how I don't have to look at the rest of that shape. So if this is x, that's x. And same thing. It's just a coincidence that these are both x. They didn't have to be equal. So if that's x, this is x. And same thing, these two are tangents. So if that's 3, this is 3. And then there we go. So if that's 3, this is 3. So perimeter means to add up all the sides. So I'm going to circle them so I know. I've got 1, 2, 3, 4 x's plus 1, 2, 3, 4 3's. 4 times 3 is 12. And I know altogether that that's supposed to equal 18 because they told us that that was our total. So if we subtract 12, we get 4x equals 6. Divide by 4. And this doesn't go in evenly, but it's a nice fraction. So we get 6/4, which divide both of those by 2, is 3/2, or 1.5. Okay. All right, well, go ahead and give your practice a try, and good luck.